Okay, so today we want to have a look at antiderivatives of e to the x, e to the ax, e to the ax plus b. Okay, so let's think about what we know about those derivatives, and then let's reverse that process to work out what's happening with the antiderivatives. Okay, so we know that when we differentiate e to the x, we get e to the x, which means it's really simple to reverse that. That immediately tells us that if the derivative of e to the x is e to the x, the antiderivative of e to the x is also e to the x plus c, in case there was a constant value. Okay, let's think about the next one. So we know when we differentiate e to the ax, we use the chain rule, and we get e to the ax multiplied by a, which is the derivative of the inside. So we get a e to the ax. Okay, so I want to reverse that a bit more formally. So again, let's think about what we know. We know that when we differentiate the thing I've just highlighted in green, we get the thing highlighted in purple, which means that when we anti-differentiate the thing in purple, we get the thing in green. Okay, so every bit of information you know about a derivative immediately tells you something about an antiderivative. If when I differentiate x, I get y, that tells me when I anti-differentiate y, I get x. That's all we're doing. What I then want to do is think about, okay, this is what I'm trying to work out. I don't want to have that a in there. So let's manipulate that integral. So I know my rules of integrals, that's just a constant value. So this is the same as a times the integral of e to the ax with respect to x. Okay, they're the same thing, and we know that equals e to the ax. And so then we can divide by a, and we get that e to the ax with respect to x is 1 on a times e to the ax plus c, obviously. So our antiderivative here is 1 on a times e to the ax. Obviously you can write that as e to the ax on a if you prefer, and then plus c. Finally, let's think about our antiderivative if it's e to the ax plus b. So we know differentiating e to the ax plus b, derivative of e to the something, is still e to the something, and then we multiply by the derivative of the inside, which in this case is a. So we get a e to the ax plus b. And the same kind of logic applies in reversing that process. If we know that when we differentiate the green thing, we get the purple thing, so we immediately know from this that the antiderivative of a e to the ax plus b is going to be equal to e to the ax plus b. Derivative of green gives me purple, antiderivative of purple gives me green. Okay, and again, same logic, we can take this a value out and therefore divide it to the other side to learn that the integral of e to the ax plus b is equal to 1 over a times e to the ax plus b, and plus c, obviously. So antiderivative of e to the ax plus b is 1 on a, e to the ax plus b plus c. So it's really the same as derivative, except you're just dividing by that a value instead of multiplying by that a value. Okay, and this is where when we start to add in antiderivatives, it's very easy to start to mix up your derivative rules. That's why it's so important that we really practice and understand those derivative rules and embed those before we then potentially confuse things by talking about the antiderivative rules. Okay, so evaluating the following integrals, e to the negative 3x, so that is one of these, which means we'll get 1 over negative 3 e to the negative 3x plus c, of course. So 1 on negative 3, or negative a third, e to the negative 3x plus c. Antiderivative of half x squared minus e to the 5x. Okay, so we've got two different functions there. The polynomial, which we've become familiar with antidifferentiating. So we know we're going to have half antiderivative of x squared is x cubed on 3. So it's going to be half times x cubed on 3. And then minus the antiderivative of e to the 5x, which will be, I was going to say 5e to the 5x, but that would be the derivative, 1 on 5 e to the 5x plus c. Let's just simplify that first term. So we've got x cubed on 6 minus 1/5 e to the 5x, or you can write that as e to the 5x on 5 plus c. Alright, antiderivative of 3e to the negative x minus e to the x on 2 with respect to x. Okay, so again, 3e to the negative x, the 3 is not changing how you antidifferentiate, it's just the antiderivative of e to the negative x, which would be 1 on negative 1, so your a value being negative 1, so dividing by negative 1, e to the negative x, that's just negative e to the negative x. And then the second term here, this is e to the half x, so your a value is half there, so you're going to have minus 1 on half, e to the half x, or x on 2. And then plus c. So 1 on negative 1 is just negative 1 times 3, so negative 3e to the negative x, minus 1 on a half, dividing by a half is the same as multiplying by 2, so it's minus 2e to the half x, or x on 2, plus c. Part D, we're going to need to simplify before we can antidifferentiate because we have a quotient of two functions there, so we need to simplify it. We do that by splitting it into two separate terms. Okay, 1 plus e to the 4x over e to the x is the same as 1 on e to the x plus e to the 4x on e to the x. 1 on e to the x is e to the negative x. E to the 4x divided by e to the x, subtracting those powers, is e to the 3x. Simplify your expression first. We haven't antidifferentiated yet, so we've still got our integral signs. Now we're ready to antidifferentiate so we can lose them. Antiderivative of e to the negative x, so dividing by negative 1 gives you negative 1, e to the negative x, plus antiderivative of e to the 3x, dividing by 3, e to the 3x, plus c. Okay, so here we've got some e to the ax plus b, so remember it's just 1 on a times e to the ax plus b. So in this case a is negative 2, so it's going to be 1 on negative 2, e to the 7 minus 2x, plus c. Here we've got a product of two functions, so we need to expand that out before we can do it, although actually in this particular case we don't. So we could do this in two different ways. Let me do it, I'll do it by expanding it out first and then I'll show you how we actually don't need to. So if we expand this out, this is e to the 1, so when we expand that out we get e to the 3x plus 1 minus 2e to the 3x, and then we can differentiate that, so it's going to be 1 on 3 e to the 3x plus 1 minus 2 on 3 e to the 3x plus c. Okay, the other way we could do it is to recognise that e minus 2 is just a constant value. That's not affecting the integral at all. E is the number, 2.718, minus 2, so 0.718, so it can just go out the front. So we actually just have e minus 2 times the integral of e to the 3x, which is e minus 2 times 1/3 e to the 3x plus c. So you could leave it written as some version of that. And if you were to expand that out, you would get exactly the answer that we got up here. Okay, so same thing, depending on how you choose to think about that. Okay, work today practicing antiderivatives involving exponential functions is from exercise 11D.